Guinea is blessed with considerable mineral wealth. Gold in the northeast and northwest of the country, diamonds in the southeast, iron ore in the southeast. But it is the bauxite resources in the west which are by far the most important in terms of size and economic benefit to the country. Guinea's bauxite deposits result from the intense weathering some 15 million years ago of sediments and dolerites containing aluminium-bearing primary minerals. Under this climatic regime, the silica and most other elements were preferentially leached out, resulting in iron minerals migrating either to the surface to form a cap or migrating downwards to form an iron ore laterite zone, with the bauxite ore sandwiched between these two iron-rich zones. This bauxite-rich mineralization tends to be found at the top of large, flat-topped plateaus covered by a thin layer of topsoil. The bauxite layer is continuous but varies in both grade and thickness across any given plateau. Guinea's bauxite is considered world-class in terms of both purity and quality. Ore purity means that the ore contains between 38 and 51% alumina, with the occasional spot highs of 65%, whilst its ore quality is described as the percentage of unwanted and reactive impurities, of which silica is the most significant, which averages only about 2%. Guinea Alumina Corporation, known as GAC, is one of the newest and yet already one of the most important miners of bauxite in the country. Furthermore, it is one of the largest greenfield investments in Guinea in the last 40 years. The concession, which covers 690.2 square kilometers, is located almost equidistant between the provincial towns of Sangaredi and Bokeh in the northwest of the country. The areas adjacent to GAC's mining concession have hosted bauxite mining since the 1970s. GAC is mining its bauxite at a rate of 12 million tons a year. This operation, both in terms of mining as well as planned maintenance of equipment and infrastructure, takes place on a continuous 24/7, 365 days a year basis. The mining itself can best be described as a simple surface mining operation. The topsoil, usually less than 1 meter in thickness, is stripped off by a bulldozer, loaded into trucks and stockpiled in preparation for future rehabilitating of the mined-out area at a later stage. The hard iron-rich capping on top of the plateaus, usually 1.5 meters in thickness, is removed and loaded by an excavator into trucks and placed onto a waste stockpile, from where, once the bauxite has been mined, it will be returned as the first part of the rehabilitation process. The third part of the process, the mining of the actual bauxite to be exported, can now take place. A block of ground is drilled, using 2 drill rigs. From these 140mm diameter blast holes, chip samples are collected for analysis to determine which dig blocks will be excavated and in what sequence. This allows final blending with other suitable dig blocks to yield a final grade of export ore which matches our client's grade requirements, possibly after blending with ore from other plateaus to provide the necessary final product specification. Once the dig block has been blasted, excavators fitted with the GPS and fleet management systems load the broken ore into a fleet of 42 haul trucks for transport along specially built mine roads, of which there are a total of 30 kilometers, to a horizontal primary crusher, and then onto one of 2 secondary horizontal breaker feeder type secondary sizes, where the ore is reduced still further to allow easier handling and transport. Any final adjustment to the required grade is achieved by blending ore of varying grades from various dig blocks at this crushing stage, with the ore being continuously analyzed. The crushed ore is then fed via a conveyor at a rate of 2,500 tonnes per hour to a rail-mounted stacker which loads the ore into one of 2 stockpiles, each with 165,000 tonne capacity, located parallel to the rail track in preparation for loading into rail wagons. The ore train consisting of 120 wagons, each capable of holding 85 tons of ore, is then loaded from the stockpile by a fleet of 4 front-end loaders. The load rate equates to less than 2 minutes per wagon, or 40,800 tons a day. Loaded trains at a rate of 4 a day, each with 10,200 tons of ore, travels on 7.9 kilometers of GAC-owned and operated track, moved by the company's own shunting locomotives, before joining 90 kilometers of shared rail for the 90-kilometer journey to Kamsar. On this journey along the shared rail, the ore wagons are moved by a set of 3 hauling locomotives. The main line is a shared facility between 3 mining companies with train slots coordinated on a capacity-sharing basis. Upon arrival at Kamsar, the loaded train leaves the shared rail network, where GAC's own port-based shunting locomotives take over and enters GAC's port platform area, once again travelling on GAC-owned and maintained rail track, which within the Kamsar platform area totals 9.5 kilometers in length, which can store up to 4 loaded trains. At the GAC port facility in Kamsar, the wagon trains pass through the car dumper, where 2 wagons at a time are automatically positioned within a cradle and totally inverted, dumping the loose bauxite into receiving hoppers. The bauxite is then conveyed towards the port stockyard area. At this point, the port control room will decide if the bauxite should be stacked and reclaimed later, or alternatively, loaded directly onto a waiting barge at the berth for immediate export. Train unloading times are 1.5 hours if the bauxite material is being stocked, or 2 hours if direct loaded into a waiting barge. In the port stockyard, the key piece of equipment is the stacker reclaimer, which can stack material at 7,500 tons per hour to a total capacity of 460,000 tons, which equates to over 2.5 export vessels. Importantly, the stacked material lies upon a specially designed and engineered draining system, which evacuates any moisture that migrates out of the stacked product, as well as coping with the seasonal rains. The stacker reclaimer recovers material from the stockpiles within a quality control plan. This is achieved by a rotating bucket wheel with toothed buckets that cuts into the pile and transfers it onto a 4.5 kilometer conveyor, which discharges at the bauxite berth. The bauxite berth, which is located at the end of the 1.5 kilometer jetty trestle and is where 13,000 tons capacity self-propelled barges are moored for loading, after which they travel 37 kilometers to the offshore transshipment zone. At the transshipment location, 2 floating cranes equipped with clamshell grabs are moored on either side of the Cape-size vessel, allowing the bauxite to be unloaded directly from the barge into the export ship. These ocean-going vessels are approximately 300 meters long and 50 meters wide, that is about 3 football pitches end to end, and hold around 180,000 tons, which is the equivalent of 15 barge loads, and take 4.5 days to load. Once fully laden, the vessel will sail to the customer's destination, and the cranes will then shift their attention to the next scheduled vessel. GAC's mining and export capacity equates to approximately 73 Cape-size vessels being loaded and sailed per year.